So now we're going to look at how to solve a new type of equation. We've talked about absolute value. We reviewed that. We looked at some basic things with absolute value. Now we're going to solve absolute value equations. So first one, this is like what we looked at in class to sort of introduce this, is what if the absolute value of x equals 2, what can x be? Okay, a number line, if you need to draw a number line on these to help you, that is a good idea. You don't have to, but that might be a help if you need to think through the problem. So what kind of numbers have an absolute value of 2? Well, 2 has an absolute value of 2, and negative 2 has an absolute value of 2, right? Both of those are 2 spaces from 0. So this has 2 solutions, x equals 2 or negative 2. You usually want to use the word or. You might see x equals plus or minus 2. That means x can be positive 2 or negative 2. Or you might see x can be, and they'll give you the set notation with the squiggly brackets, 2 and negative 2. And they'll put those 2 solutions in the little squiggly brackets. Okay? Next one. The absolute value of 5z equals 40. So we have something where the absolute value is 40. So we're saying the absolute value, and I'm going to put a little question mark in there, the absolute value of something is 40. Well, if I look at a number line, 2 things have an absolute value of 40. 40 does, and negative 40 does, right? So that something has to equal 40, or that something has to equal negative 40, okay? Well, the something here is 5z. So either 5z equals 40 or 5z equals negative 40. So now we have 2 equations to solve. We're going to divide both sides by 5 on the first one, and we get z is 8. And then on the second one, we're going to divide both sides by 5, and we get z is negative 8. Okay? So the solutions to this one are 8 and negative 8. Either one of those will make that true. All right, the next one, the absolute value of w minus 3 equals 4. Well, what kind of numbers have an absolute value of 4? 4 has an absolute value of 4. Negative 4 has an absolute value of 4. So this thing that's in the parentheses, not parentheses, I'm sorry, in the absolute value symbols, w minus 3 can equal 4, or w minus 3 can equal negative 4. Now it's two equations to solve. W minus 3 equals 4. We're going to add 3 to both sides, and w equals 7. For w minus 3 equals negative 4, we're going to add 3 to both sides, and we get w equals negative 1. So either w equals 7 or w equals negative 1. All right? Same thing for this fourth one. The absolute value of 2v minus 5 equals 17. Well, what kind of numbers have an absolute value of 17? 17 does, negative 17 does. So this thing inside the absolute value symbols, negative 2v minus 5, notice the absolute value symbols are dropped here when I'm solving. It has to equal 17, or negative 2v minus 5 equals negative 17. So I have 2 equations to solve. A couple things to point out. Notice that the absolute value symbols are not down here where we're solving. We cannot finish if it's still in the absolute value symbols. We have to break it free. Those are like prison bars. We break it free by setting it equal to the positive value and the negative value. Also notice, no sign here changed. It was negative 2v minus 5 in the absolute value. It's negative 2v minus 5 when we're solving. We're not taking the absolute value of negative 2v minus 5. We're asking what has an absolute value of 17. And so whatever that is, and in this case it's negative 2v minus 5, it equals 17 or negative 17. So negative 2v minus 5 equals 17. We are going to first add 5 to both sides, and we get negative 2v equals 22. We're going to divide both sides by -2, and v equals -11. Then we're going to solve the second one, same way. We're going to add 5 to both sides. Here it equaled -17. So we get -2v equals -17 plus 5 is -12. We're going to divide both sides by -2, and we get v equals 6. So v equals -11, or v equals 6. Okay, what if there is stuff outside the absolute value bars? This first example here, we have the absolute value of y minus 8 equals -5. Well, if there is stuff like this -8 outside the absolute value bars, we can't solve yet. So your first step before you do anything, you must isolate the absolute value. And I'll put symbols. You must isolate the absolute value symbol, okay? So this is going to be equation work here. If I have the absolute value of y minus 8 equals -5, and I want to get rid of that -8, I have to use inverse operations, right? So I'm going to add 8 to both sides. I get the absolute value of y equals -5 plus 8 is 3. Once that absolute value is isolated, the absolute value of y is all by itself, and it equals 3, then I can split it up and find my two solutions. What kind of numbers have an absolute value of 3? Well, y can be 3, or y can be -3, right? And I really don't have anything to solve here. I'm done. Okay, let's look at another one. -2 times the absolute value of z plus 3 equals -14. So find your absolute value. It's the absolute value of z plus 3. This -2 is in the way. It's -2 times z plus 3. Make a note. You will never, ever, ever, ever distribute into an absolute value symbol. Can't do that, okay? So we're going to divide both sides by -2 to get rid of that -2. Those will cancel. I'm left with the absolute value of z plus 3 equals -14 divided by -2 is a positive 7. Now my absolute value is all by itself. The absolute value of z plus 3 equals 7. What kind of numbers have an absolute value of 7? Well, that means z plus 3 can be 7, or z plus 3 can be -7. Now I'm going to solve these two. Z plus 3 equals 7. I'm going to subtract 3 from both sides, and z equals 4. Or z plus 3 equals -7. I'm going to subtract 3 from both sides, and I get z equals -10. Okay, here's two more where we have to isolate the absolute value. This one says the absolute value of 2w minus 4 all over 6 equals 3. So this is like the equations that you guys have been struggling with a little bit. I have the whole thing divided by 6, so I've got to get rid of that 6 first. So I'm going to multiply both sides by 6. Hopefully we're getting better at these. My 6's cancel. I'm left with the absolute value of 2w minus 4 equals 3 times 6 is 18. Now that my absolute value is isolated, I say, what has an absolute value of 18? 18 and -18, right? So 2w minus 4 can equal 18, or 2w minus 4 can equal -18. Now, this right here, and I didn't write that where you could read it very well, did I? This right here, these two equations, you should be able to solve without any problems, right? So I'm going to add 4 to both sides. On 2w minus 4 equals 18. I get 2w equals 22. Going to divide both sides by 2, and w equals 11. On the second one, 2w minus 4 equals -18. I'm going to add 4 to both sides. I get 2w equals -14. Going to divide both sides by 2, and w equals -7. So my two solutions, which you often get with an absolute value equation, is w equals 11 or w equals -7. All right, next one. 7 times the absolute value of 4n plus 8 minus 6 equals 106. Notice this is sort of like a two-step equation, right? I've got 7 times something minus 6 equals the 106. So the first thing I'm going to do is add 6 to both sides. I'm going to get 7 times the absolute value of 4n plus 8 equals 106 plus 6 is 112, right? Then I have 7 times the absolute value of 4n plus 8. So I'm going to divide both sides by 7. The 7's cancel, and I get the absolute value of 4n plus 8 equals 16. Now, what kind of numbers have an absolute value of 16? 16 and negative 16. So 4n plus 8 equals 16, or 4n plus 8 equals negative 16. These are two-step equations. First one, 4n plus 8 equals 16. I'm going to subtract 8 from both sides. I get 4n equals 8. I'm going to divide both sides by 4, and n is 2. Second one, 4n plus 8 equals negative 16. I'm going to subtract 8 from both sides. I get 4n equals negative, is that 24? I'm going to divide both sides by 4, and I get n equals negative 6. So for this problem, n can equal 2, or n can equal negative 6. Never forget, you can take these two solutions, you can plug them into the equation, and they should make the equation true. All right, as with many things in math, there are special cases. The special cases of absolute value equations is that the absolute value of a number is never negative. Okay? Absolute value is a distance, right? It's the distance from 0. We never measure distance negatively. We measure distance in positive units. You never go negative 5 miles somewhere. Even if you're driving backwards, because I know somebody's thinking that, absolute value or distance is never negative, okay? So this first question says the absolute value of x equals negative 6. Is there a number whose distance from 0 is negative 6? No. The distance of 6 from 0 is 6 spaces. The distance of negative 6 is 6 spaces, right? So there's nothing that satisfies this. So we say no solution, no can do, okay? All right, what about the next one? Negative 3 times the absolute value of 2x plus 1 equals 21. Well, this one's not isolated, right? We have this negative 3 times the absolute value. Remember, you never, ever, ever, ever distribute a negative 3 into an absolute value. The only thing we can do here is divide both sides by negative 3. So those negative 3 canceled. Negative 3's cancel. I have the absolute value of 2x plus 1 equals negative 7. Okay, my absolute value is isolated, and it equals a negative. Can the absolute value of a number ever be negative? No, this has no solution. But when you looked at where it started, it was a positive number. When we isolated the absolute value, it was negative, and so it didn't work, okay? So you have to isolate first before you can decide if there's no solution, all right? You cannot decide if it's no solution unless the absolute value is isolated. I think we had an example a few minutes ago. If you look at the problem, negative 2 times the absolute value of z plus 3 equals negative 14. There was a negative there, but the absolute value wasn't isolated. When we divided both sides by 2, that became by negative 2, that became a positive number, and we could work it. So you cannot decide no solution until the absolute value is isolated. All right, you're ready for some practice.